Thank you. Thank you, Kate, and great to be here this evening. Thank you all for making it through this wonderful weather that we've had today and for the last few weeks, actually. But I'm delighted to join you this evening just to talk actually through some of the ways that BT are working hard to improve our digital lives. And also today, and a bit of a theme for the topic today, is how we're doing that in a more sustainable, energy efficient way. And, you know, I think from the world around us, we can see how critical that has become, and I think is quite transformational for us. And so we'll take some thoughts on that. But this is a bit about stimulating some work that I think we as an industry need to do as well. And so we'll talk more about that. But first, let me just say, and I'm not quite sure it's going to be that stimulating start to the working week, but we'll give it a go. But let me just start by telling you a little bit about BT. The numbers here on this slide speak for themselves. It gives you a sort of a view of the size of BT. You know, not just the 30 million consumer customers that we have in the UK, but also a presence in over half the globe with 180 plus countries that we serve. You know, and really a base that continues to be resilient, even in the face of hugely competitive fibre and mobile markets across the world, and particularly in the UK. Now, whilst we are a global company, it's in the UK where we have our largest footprint. If the previous slide talked about the scale of our customer reach, this gives you some insight into the sort of scale of our technology assets. So let me start with 565,000 kilometres of duct. That's 15 times the circumference of the Earth. That's one of those interesting soundbite statistics that I throw out relatively frequently. 20,000 cell sites that we have across the UK. The UK has about a total of 40,000, split sort of 50-50 between two joint ventures between mobile operators, so ourselves and Three UK are in one asset sharing venture, and Vodafone and Virgin Media O2 are in another. That's a critical one. Some familiar assets here. We all, of course, recognise those. 20,000 of those remaining. Becoming really famous now for generating lots of Instagram uploads from tourists and virtually no phone calls. But of course, and actually quite a bit of continued conversation about what do we do with them. And you'll have seen many of them are local libraries, sites for defibrillators, or various other innovative uses that we've seen for our red phone boxes. But what we've also done, if you look to the second from the left there, is we now have 1,000 digital hubs where we've taken the phone box site, we've replaced it with a digital equivalent. We've created room for a small cell for, you know, either, well, we've got Wi-Fi in there anyway, but small cells for mobile densification. And actually, I think a slight other advantage is they probably smell a little bit better when you get close to them as well. But we're working hard on that. And so that's just the physical stuff you can see, but, you know, a wealth of assets there that we think are unmatched, certainly in the UK. Now, you know, we also have the largest core network in the UK. We have the biggest spectrum portfolio, and also, you know, the largest availability of high bandwidth connections, in particular looking at 10 gigabit per second now being a typical sort of high bandwidth connection point for customers. Nearly 4,500 of our mobile sites that I previously described now connect over 10 gigabit per second fibre connections, truly giving them a best-in-class performance both now and into the future. And we'll talk more about that a little bit later. One of the things we continually try and do in my industry is to reinvent ourselves. We tend to reinvent mobile every 7 or 8 years and add a new G. What we're less good at doing is switching off the former variants of it. And so, we've still got 2G, 3G, 4G, and now 5G. With a further variant of 5G called 5G standalone starting to appear. So managing generations of technology for us is a real critical challenge for us. And again, not least as we get to start thinking about energy. We'll talk a little bit more about that shortly. But what does this mean for a customer? Well, first it means that, we're leading the UK across many aspects of fixed and mobile. On mobile, we have, by quite a long way, the largest 4G coverage, so 2,500 square miles larger than our nearest rivals. That's more than the combined area of most of the UK's national parks, which are always the most hardest place to put the antennas. So that's a critical advantage for us. We now cover well over 86% of the landmass of the UK. The other thing you'll notice in mobile, if you're an avid watcher of the way we market ourselves, and so this has started out on 5G, is that the first thing we talk about is how many towns and cities we've passed. And then once that's got everybody's about the same, we then start talking about population coverage, because obviously the population is concentrated into the towns and cities. So we're now talking about, exceeding 50% 5G population coverage. Once that starts to even out between myself and my three fellow competitors, we then talk about geographic coverage, because that's by far the hardest to achieve in the UK landmass. We have been quite unique in setting a long-term target for that. So we fully are working towards 5G being available to 90% of the UK geographic landmass. And actually we're saying we'll give you 5G wherever you need it. You've seen our ads of having a shave on the top of Snowdon. That is, that's quite a good thing. Good little, I don't know if I dare call it a gimmick. I'll get shot by my marketing colleagues. But actually, we have linked to that we do have the intent to find ways of making 5G available wherever you are in the UK. And, we believe that between now and the end of the decade, technology will be such that, there'll be many ways to assist us in that. But for now, also what's critical is what happens with that network, particularly at peak times, so when we're all wanting to use it. What's really important actually is how does it behave for, say, the 95th percentile of customers. And our average speeds right now in the UK on mobile are double anybody else's on that. So, continuing to focus on driving capacity as well as coverage is a critical factor of any telecommunications network. If we look at the fixed network, we certainly handle more traffic than anybody else at peak times, and that forever increasing by our ambition to connect and to fibre up 25 million premises by 2026. And just this month we announced that we are a third of the way there. There's still some ways to go after the 25 million, because there's about 31 million premises in the UK. I guess the other interesting thing about this chart is, despite the fact we are quite mobile device centric as individuals using data, we're very fixed network centric in how that data gets to your mobile device. So a lot of it's still being, over Wi-Fi when you're in the home. Hence we still see significantly higher amounts of data over our fixed network compared to the mobile network. So all of this work is essential, as it's the foundation for what our networks will have to deal with in the future. Demand for connectivity is certainly rising all the time, whether it's for access to it, for the speed of it, for reliability within it, and for performance over it. And the requirement to provide this is being amplified across both consumers and enterprises. For consumers, we're seeing rapid increases in demand for content, most notably from over-the-top video right now, but also gaming and looking into the future to virtual and augmented reality. And for enterprises, it's about maximizing some of the new technologies to create opportunities for productivity for an enterprise. So in particularly at the edge of the network, where speed and latency are essential. So it's pretty clear that the volume of data will continue to increase. Highly likely that that will continue to be exponential, certainly over the next decade. And that, of course, creates some real engineering challenges for us, but also some real opportunities as we look to roll out an unbeatable 5G network and fibre to the premise. And we'll come back to that shortly. But that is how we see the end state of our network. Last summer we put convergence at the heart of a new network vision for the UK. Now customers don't know it as convergence. They'll simply know that we will provide a dependable connection at the times and places where customers need it most, without having to worry about, is mobile better than Wi-Fi in this particular location? Do I need to make sure that I download this bit before I get on the train so that when I lose coverage on that certain part of my commute, I can carry on watching last night's episode of I'm a Celebrity, Get Me Out of Here, or whatever we do on our commute. But at the heart of this actually is, and the one thing that we really learnt in BT during the pandemic is that coverage and speed are critical on networks, but are now probably second and third in priority to number one, which is reliability. That really did shift during that period, and ensuring that we have, that ability to use both networks. And if you include public Wi-Fi, 3 means of accessing data, we think that will certainly give, a great reliability and resilience into that network. We're continuing to enhance that, notably through edge compute and network cloud, and of course underpinning that by converging the core of networks. Interesting differences between fixed and mobile. In fixed, we've been on a journey of pushing the sort of authentication features right out to the edge of the network. So we try and authenticate who you are as quickly as possible at the edge of the network. We say, Mr. Whitley, subscribe to this, he's entitled to this package. In mobile, we do it the other way. We trombone it all right into the center, work it out in a couple of computers sat in a data center, and then go back out to the components and say, actually provide this level of service. Convergence is starting to treat those two in the same way, and actually the economics that we've achieved on the fixed network, although there's plenty to do there, we're starting to roll across into the mobile network as well. And that's very critical for the next phase of services, particularly on 5G, and this suite of services called 5G standalone. Now, as I mentioned earlier, this is the broadband demand growth curve, which as a network guy, two factors about this. One is it means I can say to my team, all 7,000 of who work in networks, what an amazing growth business we work in, until you look at the revenue chart. And then also, secondly, it's quite a scary chart when you're trying to build a network to make sure that the peak traffic that we deliver, we can do in a way that's not over-contended. Our latest peak was 26.17 terabits per second on the 19th of October. And that's when Amazon Prime were screening Premier League football. And actually on that date, 5 of these matches were live streamed simultaneously. And so, we've got to continue to make sure that we build for that growth. Now, typically the peak occurs, and this was good news. I remember one of our largest UK-based customers rang me up in February 2020 and said, we're thinking we might have to send everybody to work from home. Will it work? And I said, no problem. Brave thing to say, but that's because I knew the peak was between 7 p.m. and 9 p.m. in the evening. At the time, it was 17 terabits per second, so look how much it's grown in a couple of years. And during the day, we were only achieving like 4.5 terabits per second. So there was loads of room for the network to accommodate working from home during the day, because the reality is broadband networks are driven by people watching streaming video in the evening or doing downloads of popular games. And so, you know, in our role, we get very obsessed with charts like this, which essentially show when the peaks have occurred, you know, over recent times. You know, and actually, you know, I mean, I remember about 5 years ago, we used to obsess over the Great British Bake Off, because that moved from the BBC to Channel 4. And Channel 4 decided, we've got a good idea, we'll load our CDNs, our content servers, with the Great British Bake Off, which means if you want to stream it, you can fast forward through the ads. But if you watch it on broadcast TV, you're going to have to wait for the ad breaks. And actually that drove quite a lot of people online as a way of watching you know, the Great British Bake Off. That was what drove the peaks actually before this graph started. Since then, it's either been football or it's been when the makers of Call of Duty and Fortnite think it's a good idea to launch their latest release on the same day at the same time, usually 7 p.m. in the evening, and then there's a whole generation of people that rush to download it to Xbox and PlayStations as fast as possible. Whereas we'd quite like them to stagger it, just please do it on different days, which actually during COVID, working with Ofcom, we managed to convince them that that would help quite a bit if we did that. The other key thing you can see, if you look really closely here, Christmas Eve, New Year's Eve, it's really quiet on the broadband network because we're all watching TV. And when we watch when you're watching broadcast TV as opposed to streamed TV, or we might even be sat as a family talking to each other, heaven forbid. But you know, you became this sort of thing. You can see from me, I get a bit obsessed with watching human nature when it comes to what are we using the network for. We're expecting the next peak on Boxing Day because that's when Amazon typically shows some more Premier League games. Now, of course, we have to build the network all year for that peak that occurs on Boxing Day. So there's a bit about the network. I'm going to change tact a little bit now into really where I think the next era of really thinking, research, and technological development needs to happen. You know, we consume almost 1% of the UK's electricity, 2.4 terawatt hours per year. And that's a lot. And, you know, like many organisations, we're pretty keen on trying to reduce that. And where we do use it, making sure we're using it ever more efficiently. So we already, and we have for years, sourced 100% renewable electricity in the UK. And actually, 3 or 4 years ago, we added to that such that we're now proud of the fact that as BT, all the electricity we buy is from renewable sources. But if we can reduce consumption, because at the end of the day, there is only a certain amount of renewable energy that enters the grid in the UK. So if I can reduce consumption, it means more other people are making use of that renewable energy. You know, and particularly on days where it's plentiful. I mean, so for example, in October it was quite plentiful because it was warm and windy. So lots of wind power, which brought energy prices down. But even so, reducing consumption meant that others were able to use some of that plentiful renewable energy. So we're very focused on our fleet. We have the second largest private fleet in the UK after Royal Mail. Quite convenient in that, got to be careful that you don't laugh when I say this. The vehicles spend quite a lot of time not moving. When the OpenReach guy is outside your house or the cabinet doing work to install broadband or repair it. So actually they're quite efficient from an electrical vehicle perspective. So we're really keen to electrify our fleet as quickly as we can. We've got about 35,000 vehicles we've electrified. A couple of thousand now. Actually, mid-sized vans have been a bit of a challenge because most of the focus, of course, has gone on to electric cars and less onto electric vans. We're also working hard to rationalise our office space, moving down to 30 locations where we house employees and colleagues from about 450 today across the UK. But the reality is 95% of energy is used by the network. And so how we drive down consumption in the network is critical. And that's because our networks are a complex set of diverse functions, each with different evolution plans, as I mentioned earlier. We have a lot of legacy infrastructure still in the UK, such as the public switch telephone network. And 3G, my other wonderful soundbite is if you were to look at a radio mast, quite a sad thing generally, but people like me do look at them. And if you look to I could tell you that 2% of mobile data is going over the 3G network and the antennas and electronics that you can see there. Unfortunately, it's consuming 37% of the power. And that just shows the era of electronics that is used in those locations. So, a real push to drive customers towards newer strategic networks. And of course, we talk about the newer strategic networks as being significantly more energy efficient. 5G is much more energy efficient when it's full. But when you first put it out there with not many people on it, you're actually using more power. And so that balance of how we roll that out, migrate customers across, is really important in terms of building networks. This on the right-hand side here is a Nokia 7750. It's a sort of combined router and switch. We have 4,500 of those in the network, located at around 2,000 sites across the network. Basically, they terminate all of the access, whether it's mobile or fixed, convert it into IP, and then we route it across the network. Now, the pie chart on the left shows the biggest sources of energy consumption in those devices. External cooling, so having to cool that thing inside a data center consumes a lot of power. And then the other piece, that sort of grey colour area, is forwarding packets. So basically a packet comes in, you have to look at the header and say, is it for me or is it for somebody else? Most of the time it's for somebody else, so you have to send it on. And you've used energy in that process. So we've got to continue to think about how we make these more energy efficient. And so as you'd expect, we're exploring many avenues to reduce power consumption across a range of different timescales. We're investigating clearly where can we turn things off, particularly as I've described the less efficient legacy equipment, how we can do that faster by altering the architecture or deploying new technologies faster. We're making sure that we're getting more smart on power saving modes. We're all used to consumer devices switching themselves off if you leave them on and going into sleep mode. Unfortunately, most network electronics doesn't do that. So right now we're working really hard to work out how many mobile carriers should I switch off from that base station or that tower through the night and then turn them on again in the morning such that I can save some power over night time when there's less customers. You might be quite surprised we don't already do that, but actually we don't, and that's something we're now starting to focus on. We're also looking at ways that we could change the topology. So we have 106 large locations in the UK where we interconnect with customers and other operators. If we reduce that to fewer and use more transmission and less switching and routing, could that contribute towards reducing energy? Where are we getting on optical switching? Because we certainly know that switching photons rather than electrons and needing less bias current for the silicon has opportunities in terms of reducing energy consumed in switching. And we also know that they are faster than optoelectrical switches, less likely to age as quickly. The bathtub, the far side of the bathtub is further away, and so potentially longer life. So we see some interest in new materials there and a lot of innovation in this space that we're encouraging in terms of how we can drive forward that reduction in energy consumption. I mentioned optical switching. Again, you might be wondering, why aren't we already using it? The challenge here is to make a good optical switch. We need a non-linear material, so that if we shine a beam of light onto it, it changes the properties of another beam of light traveling through it, so that we can create a switch. And to build a good switch, we need materials that can do that without the rather high power lasers that we need to enable that today, because that defeats the object of needing less energy. So a lot of material science, we think, here in order to get optical components with ideal energy consumption. Similar things apply to, I guess, the ubiquitous CMOS components. Well-established technology for digital integrated circuits and for analog radio frequencies, circuits and sensors. Vital for designing high-performance, low-power devices of the types we need in our network. They consume energy in two ways: dynamic consumption when they're actively switching, and static consumption due to leakage when in standby mode. Faster processing speeds are driving up that base power consumption of these devices. And there's also, as we continue to reduce the size of the wafers, then we get more loss through static dissipation, and that becomes more significant in smaller devices. So again, we encourage what's happening in terms of looking at newer materials to enhance CMOS and add to that to give a lower power consumption and indeed a lower cost of the materials. And this table here is from the Royce Institute, which shows some of the possible solutions with potential timelines for that. We also saw earlier that cooling of components is a really large component of our energy use, up to 40% in some cases. Could we completely remove the need to cool, to build data centers with forced air cooling through hot and cold aisles in order to do that, and fans inside most of the electronics? Now, conventional components that typically operate around 70 degrees C or 125 degrees for military applications, but we have recently seen components that can operate reliably at 150 degrees C for potential applications initially in cars and aircraft. Could we look at those materials in telco equipment and run them hotter? Now, of course, the maximum operating temperature depends not only on the device itself, but also on the packaging material and the technologies used to house the device. So, a lot of focus on how we disperse the heat. And again, innovations there. Of course, the other challenge is if you run it at high temperature, typically they don't last as long. So how can you get the life out of a component running at a higher temperature? Most of the equipment we deploy today, we're looking at certainly 10,000 plus hours. If you look at the PSTN equipment that we deployed in the 80s, it's been running for 250,000 hours. And so you can just see the sort of lifetime that we need out of the electronics, which again, temperature is critical for that. Other ways are looking at how we can have materials which make cooling more effective and efficient. One option which might be a bit counterintuitive, and you can see in the picture here, is to submerge the electronics in a liquid. Clearly not a liquid that's conductive or capacitive, but one that's certainly a good thermal conductor, so that we can draw heat away. That 7750 that I showed you earlier, you can see here, submerged in a mineral oil in an attempt to keep it cool. And we think that that's one way of potentially removing that 40% of power consumption, as we don't need to run the fan on the router. So we've been running one for 9 months in the labs. I think we told Nokia we were doing it and are working with them on it. But it's something we're keen to work with our suppliers on as, again, ways of reducing electrical cooling. Another option here, you can see at the bottom, is a Peltier cooler, where effectively we can use that effect to pull heat away from the devices, because it's not the whole circuit board, clearly, it's just particular localized areas where we can focus on removing the heat. And then just one, so these are all quite practical, I would say, engineering challenges of how to solve the problem of reducing the energy consumption of the current sort of technologies that we use today. Just to finish on one other area which we're pretty excited about is what happens if we remove the metal completely. And even in many cases the silicon as well. And one of the areas we're particularly excited about, which you can see here, is a new technique for detecting radio signals called a Rydberg receiver. So this is using red and blue optical lasers to prepare and excite rubidium atoms. They have a single unpaired electron in the outer shell that, once excited to that point by shining a laser, the electron's pulled a little bit further away from the atom's core, and in that position can then amazingly, but not that amazingly because the physics tells us it can, but amazingly from an engineering point of view, it can detect electromagnetic radiation. So if you start pointing 3.5 gigahertz radio waves at it, and then you can then use another laser to start detecting those radio waves. So we see that as an antenna with no metal. And the potential of having that in an optical fiber, running from telegraph pole to telegraph pole across our existing network, and using that as a really high sensitive receiver with very low energy consumption is something that we're particularly excited about and have patented and got a published paper on. So it's something that it's a good example actually of where we at BT still believe in getting a little bit close to fundamental research. Tim will talk about the fact, because I keep pushing him, that it's about applied research, and it really is. And this is a great example of where taking some ideas from physics and looking at applied examples of those, we can see ways of potentially completely transforming how we build a radio receiver, and then transforming the whole network through that. So something that we're quite excited about. And one of the great things that we're proud of at BT, because there's certainly no other telco in the UK doing this, and not that many on the globe. Many of the historic telcos who led the way in the early days, thinking of, we were at Bell Labs recently, but of course it's not part of AT&T anymore. And so the fact that we as BT still do this links very much to our purpose, which is connecting for good. That for us means being the most trusted connector of people, devices and machines. That word, there's a whole new topic and separate lecture about the trusted component, hence my role now as Chief Security and Networks Officer. But certainly to deliver this ambition is, we absolutely believe requires a really close collaboration of academia and industry, of world-leading science and engineering. And it was great to see some of the larger industry ambitions restated in the autumn statement, about innovation and applied research in large companies in the UK, and reaffirming focusing on being a science superpower. We think as BT we've got a key role to play with that, and we're really proud of our long-standing links with the University of Cambridge and our other academic partners around the world, who are helping us to deliver on that ambition. So with that, thank you for working with us here at Pembroke, and thank you for listening this evening, and over to Tim for Q&A. Tim.